I'm going to walk through how to do section 7.9. So first thing you have to do is follow the directions on Canvas to join, make an account, join the class using your class code. So look for the period 1, 2, or 4 code. Follow those instructions first, and then once you get that set up, if you need more help with the directions for using the gizmo, that is the purpose of this video. So we're going to start by launching the gizmo. So again, you should already have signed up and logged in. Alright, so now we're in the Ionic Bonds gizmo. We hit launch, and there's a prior knowledge question. So this is just to get you thinking about what you're going to be doing. And it says, ponder. Nate and Clara are drawing pictures with markers. There are 7 markers in a set. Nate has 9 markers and Clara has 7. What can Nate and Clara do so that each of them has a full set? So you're going to write down in that space what you think they can do. And then we're going to move into the gizmo warm-up. So just like students sharing markers, atoms sometimes share or swap electrons. By doing this, atoms form bonds. The Ionic Bonds gizmo allows you to explore how ionic bonds form. So first thing we're going to do is we're going to check that sodium is clicked on the gizmo and chlorine are selected on the gizmo, and they both are. Then what we're going to do is we're going to hit play. So there's a button down here that lets you hit play, and then you're just going to take a look at the electrons kind of moving around, and then we're going to go to problem 1. It says each atom consists of a central nucleus and several shells that contain electrons. The outermost electrons are called valence electrons, so that's in that very last circle or very last shell. And the question is, how many valence electrons does each atom have? So that purple looking one, you're going to count how many electrons are in the last shell. That green one, chlorine, you're going to count how many electrons are in the last shell, and you're going to write that number in these spaces right here in those squares. Then we're going to hit pause. Elements can be classified as metals and nonmetals. Metals do not hold on to their valence electrons very tightly, while nonmetals hold their electrons tightly. Remember, this is because of that trend in electronegativity we talked about and where they're located on the periodic table. So you're going to try pulling an electron away from each atom, and based on what you see, you're going to try to figure out which one's the metal, which one's the nonmetal. So you're going to click on the electron and try to drag it away, and then write your responses in these 2 boxes here. And then we're going to move on to the next thing. So we're going to click reset, and sodium and chlorine are still selected. So the intro for this, electrons are negatively charged, while protons are positively charged. Particles with opposite charges, so positives and negatives, they attract. What happens when atoms gain or lose electrons? We talked about this before, what happens to the charge. So you're going to write down in that space your answer. We're going to start with number 1 now. So observe. Most atoms are stable with a configuration of 8 valence electrons. This is known as the octet rule. How many valence electrons does each atom have? So again, you're going to look at that last shell or the last circle on these Bohr models and count how many electrons does sodium have, or valence electrons does sodium have, how many valence electrons does chlorine have, and then you're going to write your response in those 2 boxes there. For number 2, where it says form a bond, each electron has a charge of -1 or -1. Each proton has a charge of +1. You can calculate the charge of an atom by subtracting the number of electrons from the number of protons. Move an electron from the sodium to the chlorine atom, and then it asks you, what are the charges of each atom now? So we're going to move an electron from the sodium, the purple one, to chlorine, and then you can use 8-man to try to figure out what the charges would be. But the other thing that you can do is you can click on the box that says show charge, and it will show you the charge of those atoms now that you have moved those electrons. So make sure you write those charges in those 2 boxes right there. And now that they have a charge, these are called ions. So now we're going to move on to question 3. Think and discuss. Why is there an attraction between the 2 ions in this chemical bond? So go ahead, take a moment, write your response in this box here, and then we're going to move on to activity B, ionic compounds. So we're going to hit reset. We're going to turn off show charge or unselect it, and then we're going to change these atoms to lithium and oxygen. And now the question is, how are ionic compounds formed? So number 1, form bonds. We're going to click add metal to add another lithium atom. So we just added it. And then we're going to transfer electrons from the lithium to the oxygen and click check. So we're going to transfer these electrons over here, and then we're going to hit the button that says check. And now it's asking us, did you make a stable compound? And it should tell you here where it says a hint and feedback if you did do that. So you're going to write your response in that box. And it says turn on show formula. What is the formula of this compound? So we're going to put show formula, and then you'll see the little formula pop up. You're going to write that down in this box over here. And it says turn on show charge. What is the charge of each ion? So you click show charge, and now you can see the charge for all 3 of those ions, and you're going to fill that in these boxes down here. And we're going to move on to number 2 where it says practice. So we're going to use the gizmo to create stable compounds from the combinations given below. After transferring electrons, arrange the atoms to demonstrate the attraction between positively charged ions and negatively charged ions. Click check to check each compound. We're going to write the charges in these boxes here, and then the chemical formulas in these boxes here. So to change it, make sure you click on the metal or non-metal to change the atom, so make sure it matches. So for example, that first one is lithium and fluorine. And then you're going to move electrons around, and then you're going to check to see if you made a stable compound. If you did, you're going to write in the charges here. So for this first one, you would put +1 for lithium, -1 for fluorine, and then the chemical formula, it shows you here. Just write that in, LIF. So you're going to go ahead and try the rest of these on your own. And then what I'm going to show in a second is going to be the key. So if you want to check your work for the entire activity, you can do that. So here's the key for this first section here. So go ahead, you can pause and check your work. And here's the key for activity A. So again, you can go ahead and pause, check your work for this section. And then here's the key for that last section right there. So you can go ahead again, pause and check your work.